is a video on finding linear equations given to a table. So we need to find the slope and the y-intercept, or also called the starting value, from this table in order to write the equation of the line. Okay, so here's what we're going to do. First, we're going to find the slope, which is the change in y, which we represent with a triangle, over the change in x's. Okay? So to do this, we're going to take 2 points from this table. So let's maybe pick this point and this point. So my x's are the top row and my y's are the bottom row. So I'm going to take my y's minus the other y. So I'm going to start with the 9. Say 9 minus 7. So I'm going from my right to the left. And on the bottom, I'm going to say the changes in my x's. So I'm going to take this one minus the 0. It's got to go in the same order. Okay? And if you start on the right and then you subtract the left side, you need to do the same thing on the bottom. So let's do the top divided by the bottom. 9 minus 7 is a 2. 1 minus 0 is 1. So my slope, or my rate of change, is 2. It's increasing by 2 each time. So next I would need to find the y-intercept. Now first thing I want to do is look at the table and see if the y-intercept is already in the table, and it can save me a little bit of time. So my y-intercept is when x equals 0, it's the other number. Y equals something. That's my y-intercept. So in my table, I'm looking for when x equals 0, it's the y value is the y-intercept. So in this case, it's 7. Okay? When my x is 0, the other number, the y value is the y-intercept. So my equation for this table would be y equals my slope, 2, and then x plus my y-intercept, or starting value, 7. So here's the equation for that table right there. We found the slope first, and the y-intercept was already in the table. Let's do an example where the y-intercept is not in the table. So here we have a table with some data. There's no 0 in the x column, or x row, you see that. So we're going to start by finding the slope. Change in y over the change in x, or divided by the change in x. Alright, so I'm going to take my y's. Let's take maybe this number, this point. So I'm going to take my negative 19 minus, this is very important, minus negative 14. So I'm always subtracting, no matter if the stuff I'm subtracting happens to be negative. This right here is this point. So I'm still subtracting that value. Okay, I'm going to do the same thing on the bottom. So I'm going to take the x thing, negative 3, let's say minus, I'm going to do that in red, minus the other value, which is worth negative 4. So make sure you're subtracting the values. In the previous one, we were dealing with positive values. When you're dealing with negative, sometimes you run into some trouble. So I take the one term minus the other term, and I say in the same order. So now I'm going to do the top and the bottom. Let's do the operations here. So I have negative 19 minus negative 14, which really becomes a positive, or no, it becomes a negative 5. On the bottom I have negative 3 minus negative 4, which becomes a positive 1. So my slope is going to be negative 5. That's my slope, or the change. The change every time is going down by 5. Now I want to find the y-intercept. Now there's no y-intercept, remember that's when x equals 0. Okay? It's the y value. And that's not in my table, so I'm going to have to do a different approach for this. So we know our general equation for a line is y equals mx plus b. M meaning the slope, and b is the y-intercept. So far we know the slope was negative 5. So I'm going to replace that in my equation. Keep everything else the same. I just replace the m with the actual number I know it is. Now I need to find the y-intercept, which is this number right here. I don't know what that is, it's not in the table. So what we're going to do is we were going to plug in another set of points, an xy point, to find that. Okay? So I'm going to pick this point right here. You can pick any of those points you want, but I'm just going to pick the first one. And I'm going to plug those values in for x and y, so you need to be careful. So the value for x was -6. Right, so I have -5 times -6 plus, make sure I'm going to write this as a capital B so you can tell the difference between my B and my 6. And the y value is -4. So all I did was replace this term, or these points right here, x and y, into my equation where x and y were. X became -6, y became -4. My slope we already found. The only thing left to find is the b, or the y-intercept. So now I'm going to multiply. -5 times -6 gives me +30 plus b. Now to get the b by itself on that right side, I need to get rid of that 30, the +30. So I'd have to subtract 30. I want them to become 0. So now if I have +30 and -30, that's all gone. This side becomes -34, and that's b. That's my starting value. Right? So now I would write this in one final equation. Y equals, my slope was -5x, and I'm just going to write -34. You could write it as plus -34 as well. Either way is okay. So in this problem, we weren't able to just find the y-intercept from the table. So what we did is we plugged in what we knew. We knew the slope was -5, and then we replaced the values of x and y with a point from the table. And we solved that for b. Right? So you might have to do this more often than just looking at the table and getting lucky with your y-intercept being there. So plug in another point for x and y and solve for b.